Hello all, let's start part 2 of section 5.1. Still we are talking about the system of linear equation and two variable, but this time I'll discuss a different method method 2 how to solve a system of linear equation using eliminating a variable, or we call it simply addition method, correct? We call this method addition method. And this method, you are actually eliminating one of the variables and you solve your system of linear equation. Let me explain this method in one example or in few examples for you, correct? Example number 1, we will start with the easiest one. For example, they give you a system of linear equation in two variables as a 3x minus 4y equal 11 and negative 3x plus 2y equal negative 7, correct? Again, if I name my equations, this is equation number 1 and I'll name this one equation number what? Number 2. You see in this example, if I add these two equations vertically with each other, correct? If I add this way, if I add these equations with each other, one of the variables actually eliminates, correct? Look, negative 3x and positive 3x becomes 0, correct? Negative 4y and 2y gives you negative 2y. And 11 minus 7 gives you 4. Easily you see one of the variables eliminated and you only end up with one variable like this, negative 2y equal 4. And easily you can solve this equation for y by dividing by negative 2, correct? Then you can find easily y equals negative 2. As soon as you find one of the variables or one of the answers for the equation, plug in the answer in the one of the given equations. For example, I'll copy my equation number 1, 3x minus 4y equal 11, and I'll plug in y negative 2. It means 3x minus 4 times negative 2 equals what? 11. And I'll solve it for x. Then 3x negative times negative gives you positive. 4 times 2 gives you 8 equals 11. Subtract 8 from both sides. Then 3x equals 3. And dividing by 3, you can find the value of x equal 1. The answer for this problem is 1, negative 2. We call this method the eliminating method. It was very easy to eliminate this problem because the coefficient of the x's was the same, correct, but opposite sign. But let's do another example and see if they are not equal, then what's happening, correct? Let's take this system. 3x plus 2y equal 48. And equation number 2, 9x minus 8y equals negative 24. This system is not that easy like the first example, correct? In the first example, the coefficient of x in both equations were the same but opposite sign. Now, what to do to eliminate one of the variables here in this equation? In the elimination method and the addition method, I'll give you some rules now. Before solving this example, follow these rules. Rule number 1, or follow these steps, correct? or these nodes. Rewrite if necessary, let's say this way, if necessary, rewrite both equations in the form of ax plus by equals c. Correct? What does it mean? Let me explain. For example, they give you the system like this. 3x equals 48 minus 2y, and the second equation, let's say they're giving you this way. The second one like this, 9x minus 8y equals negative 24. Look, your equation number one of the variables are in one side and the other variable is on the other side. You have 2y on this side, you have 3x on this side. What you do in step 1, it says, because you are using the addition method, write this equation number 1 in the form of ax plus by plus c. It means bring both variables in one side and keep the constant on the other side. Look, you have 3x equals 48 minus 2y. For example, of course, in the example, it's not giving like this, but I'm trying to explain for you what is the meaning of a step 1, correct? What you do, you add 2y to both sides to bring both variables in one side, correct? You see, it becomes like this. 3x plus 2y equals 48. That's the meaning of a step 1, correct? But of course, in this example that I put for you in the top, you don't need to do that because the variables are already in one side. I just made something here for you. If the equation is not given in the form of ax plus by equals c, if it's necessary, first rewrite your equations in the form of ax plus by equals c. Now, step 2. Believe me, if you follow these steps, you can solve any system of linear equation by addition. Actually, I'm giving you the steps how to solve, right? If necessary, multiply either equation or both equations by appropriate number. Let's say this way, by appropriate number. Sorry of my handwriting. My pen is kind of moving on the pad. So that the sum of the x coefficients or y coefficients, so that the sum of x coefficients or y coefficients, right? The x, let's correct this, the x coefficients or y coefficients is 0. I'll explain it now here in the example. The example that I copied, you have 3x plus 2y equal 48, and equation number 2, 9x minus 8y equal negative 24. Look, choose one of the variables. Which one you want to eliminate? For example, in this system, I want to eliminate x, correct? To eliminate a number, eliminate means to change it to 0. If I want to change positive 3 to 0, if I add negative 3, then my answer will be 0, correct? Now, equation number 1 has 3x, equation number 2 has 9x. To eliminate this coefficient of, to eliminate this variable x, what I will do, I will try to find a number that multiplies with 3x. It gives me 9x but opposite sign, which your number will be what? Negative 3, correct? Look, if I multiply, negative 3 times 3x gives you 9x, negative 9x. And negative 3 times 2y gives you negative 6y equals negative 3 times 48, 24, negative 144, correct? Now, if you focus, this one becomes equation number 1, and if you add these two, you see 9x and negative 9x cancels out each other. Or you can eliminate y. If you want to eliminate y, multiply equation number 1 by positive 4. Because 4 times 2y gives you 8y. And in equation number 2, you have negative 8y. Immediately they become 0. That's the meaning of step number 2. Correct? Step number 3. Add the equations in step 2 and step 2 step 4, solve the equation, or I just say solve. Correct? Now I'll show that example for you using all 4 steps. Let me copy back. 3x plus 2y equals 48. Equation number 2, this is equation number 1. Equation number 2, 9x minus 8y. 9x minus 8y equals negative 24. Equation number 2. I want to eliminate x as I did it before for you. What I do, I will multiply my equation number 1 by negative 3. Correct? Negative 3 times 3x gives you negative 9x. Minus 3 times 2y gives you 6y. Equals, and 3 times 48 gives you negative 144. This is equation number 1. Copy equation number 2 under that. 9x minus 8y equals negative 24. Now what you do, add these two equations. Correct? Negative 9x, positive 9x cancels out. Negative 6, negative 8 gives you negative 14. Y equals 8, 6, negative 168. Correct? Now divide both sides by negative 14. These two cancels out. Y equals 12. Correct? Negative over negative gives you positive 12. As soon as I found the value of one variable, I'll plug this value of y in one of the given equations, and easily I can find the value of x, which I'll do here. For example, I'll copy my equation number 1. 3x plus 2y equals 48. Then you can write 3x plus 2 times 12 equals 48. 3x plus 24 equals 48. Subtract 24 from both sides. Then 3x equals what? 24. Divide by 3. X is equal what? 8. Then the solution for this equation is 8 comma what? 12. Always write your x first, then y. Correct? Let's do another example also for you. Example 3. I think this is example 3, right? 4x plus 5y equals 3. 2x minus 3y equal 7. This is equation number 1. This is equation number 2. It's up to you which variable you want to eliminate. Correct? You can eliminate y, you can eliminate x. Here, the easiest one is to eliminate x. The coefficient of x should become equal but opposite sign. That's the goal. Then you see, if I multiply equation number 2 by negative 2, correct? Let me first copy equation number 1 again. Here, 4x plus 5y equal 3, equation number 1. And multiply negative 2 in equation number 2, it gives you negative 4x plus 6y equals negative 14, equation 2. Now you see, if you add, these two cancels out. 5 plus 6 gives you 11y equals 3 minus 14 gives you negative 11. Divide both sides by 11, then y is equal negative 1. Correct? Now copy one of the equations. For example, this time I'll copy equation number 2. 2x minus 3y equals 7. Plug in the value of y there. 2x minus 3 times negative 1 equals 7. 2x plus 3 equals 7. Subtract 3 from both sides. Then 2x is equal 4. Divide by 2. X is equal what? 2. Correct? Enough examples? Let's talk about this example and see what's happening. I think this is example number 4. 4x plus 6y equals 12 and 6x plus 9y equal 12. Correct? Equation number 1, this one equation number 2. Let's try to eliminate one of the variables and solve this system. You see, here you have 4x, here you have 6x. Here you have 6y, here you have 9y. It's not the way that you only multiply one equation. Sometimes you need both equations to multiply with that number that the coefficients becomes equal, opposite sign to each other. Look, actually you are looking for the LCM between the coefficients. For example, if I want to eliminate x, the LCM between 4 and 6 is what? 12, right? Then what I do, I will multiply equation number 1 with 3, equation number 2 with 2. But at the same time, they should be opposite sign. I'll choose one of these numbers negative, correct? Let's do that. 3 times 4x gives you 12x plus 3 times 6, 18y equals 3 times 12 gives you 36. Here, negative 2 times 6x gives you negative 12x. Negative 2 times 9y gives you negative 18y equals negative 2 times 12 gives you negative 24. Let's add. Positive 12x, negative 12x cancels out. Oh, look at here. 18y and negative 18y also cancels out. What left on the left side? On the left side, it becomes 0. Equal 36 minus 24. How much? Gives you 12, correct? Look at here. Is this a true statement or false statement? 0 equals 12. Is this true or false? You see, you end up with a false statement, correct? This statement is false. Every time that you end up with a false statement like this, the answer for the system of linear equation is no solution. Your answer is what? No solution. And the meaning of this symbol, which we call it phi, phi means no solution. Correct? It means there is not such a number for x and y that if you plug in to these two equations, they can intersect each other. Correct? Look at now this example, then after this example, I'll explain something for you, correct? Y equal 3x minus 2 and 15x minus 5y equals 10. Even in this system, it's better to use the substitution method, right? But if you want to use elimination, you can use elimination, but also you can use the substitution method. Let's use elimination. Look at here. Equation number 1 is not in the form of ax plus by plus c, correct? Equals c. You have y equal 3x minus 2. First, subtract 3x from both sides, correct? Change the form of the equation. Then you end up with negative 3x plus y equals negative 2. Now you are in the form of ax plus by equals c, step 1, right? Copy equation number 2. You have 15x minus 5y equals 10. This is equation number 1. This is equation number 2. To eliminate x, I will multiply equation number 1 by 5, correct? 5 times negative 3x gives you negative 15x. 5 times y gives you 5y. And 5 times negative 2 gives you negative 10. This one becomes equation number 1. Now, if I add equation 1 and 2, you see these two cancels out, these two cancels out, 0. And on this side, 10 minus 10 gives you 0. 0 equals 0. You end up with the true statement. You end up with the true statement. Then the answer for this system of linear equation is all real numbers. All real numbers. It means any number that you choose for x and any number that you choose for y, if you plug in to both equations, those two numbers will satisfy both equations at the same time. Correct? Now, after this example, unfortunately, in your book, we are not talking about the graphing method, but let me show you something. Correct? At least you know how to graph a line. You already know that. When you have two linear equations at the same time, if you graph these two linear equations, there are three possibilities. Correct? First, for example, this is one of the lines that I graph, and this is one equation, and I'll graph the second equation and it gives me such a line like this. If both lines meet each other at one point, you see the lines are meeting or intersecting each other in one point, correct? In this case, your equation has only one solution, like example number 1, number 2, number 3, correct? You only get one solution. Possibility number 2. Sometimes when you graph both equations, correct? For example, one of the equations gives you this line, and when you graph the second equation, it gives you this line, another line parallel to the first line. Correct? In this case, your system has no solution because the lines cannot meet each other or cannot intersect each other, correct? Then parallel lines means no solution. Possibility number 3. Sometimes when you graph a system of linear equation, for example, you graph one of the lines and you graph the second line, the second line is actually on the top of the first line. Both equations, they are giving the same line. They are on the top of each other. In this case, you have all real numbers. Because why all real numbers? Because you see, every single point of these two lines, they are intersecting each other. That's why you have infinite many solution, or you can call it all real numbers. Correct? This was all about solving a system of linear equation in two variables. The last part of this section, there are some word problems that I will avoid those for you because I know students are coming from different categories to this class. We will do some word problems in the future chapters. For time being, we are done with section 5.1, and I will stop the lecture here and see you all in section 5.2.